Hello.
Hello, sir. Good evening.
Good evening. Yeah.
Sorry, sir. I actually joined the wrong link by mistake.
Oh, that was
So that was
that's why.
showing people no one's joining on that link. That's why
Oh,
I took some time.
no issue. That's why if I don't join in 5 minutes, just message me, right? So that if you're in the wrong room,
Yes.
you
So
just fix.
that's why when you message, I figured I joined the other link. So
Okay,
I
so what
revised
happened?
the topics you told me to.
Hmm. Okay.
So in that, so in work energy power, you told me potential energy of a spring, right?
Hmm.
So I
Yes.
didn't understand that. The other topics I revised the gravitational potential energy and so the tension, force, normal reaction. But so the work energy power, potential energy of a spring, I didn't understand.
Okay. Okay. So let's just do that first then. Potential energy of spring. Suppose there is a wall like this, and there is a massless spring. First of all, we'll just talk about massless spring. Now, ideally, whenever you're solving the questions, it is understood that the spring is ideal. It means the spring doesn't have any mass at all. If it has any mass, it will be given to you in the problem itself. So let us say that it doesn't have any mass or negligible mass. It's not possible to have zero mass. It has negligible mass compared to the block. If it is placed like this, then what happens? Let us say that a block is attached to it. If you understand the spring force, finding out the potential energy of a spring is not that difficult. It's very easy. Let us say that this is the mean position. X is equal to 0. This is called mean position. Spring force, you know the force? F is equal to what?
The spring force, so the K
Kx, right? Minus
K
kx.
minus
Minus k. Okay, let's just try to understand this force only. Tell me, is this force constant? It means it clearly tells you that the force is directly proportional to the displacement x. X is the displacement here. Displacement with respect to the mean position, right? X, you can call it, X can be called extension or compression. That is what we meant by X. So whenever there is compression or extension in the spring, there is spring force. If the extension, if it stands on the mean position like this, X is equal to 0, then force is also equal to 0. So at this position, force is equal to nothing. It is 0, right? At this position, there is no force acting on it. Okay. Now, once you have understood this thing, so it depends on if you compress it on this side or you extend it on this side, then the force comes into play. Otherwise not, right? You can extend or compress like this. So force is directly proportional to K. Is it a constant force? No, it is not a constant force. It is a variable force, but it varies directly with, it is directly with X. So force is a variable force. Now, one thing, just see this thing. In this case, what happens? Suppose the spring is at this position. Suppose it is at this position here. Then what you're doing? Obviously, if you want to bring naturally the spring will want to be at the mean position. It want to stay in the same position as it is. But if you want to move it to this position, you have to exert some force on it. And when you exert a force, suppose the spring is in this position. Suppose the spring comes in this position. Here, it is here. So how much force is acting on it when you're holding it? What is the net force acting on it?
So the spring.
Yeah. Let x is equal to x1 to the right, right? So can you tell me what is the net force acting on it now?
So minus kx1.
It is 0. Why? Because just see this thing. It is the x is equal to 0 position. And if the spring is here at this position, then you are applying a force, external force in this direction. And there is a spring force also, right? And you're holding it right in that position. Naturally, it cannot stay in that position. So in that case, two forces are acting on the system. So these forces are exactly equal. That's the body is at rest. If I ask you what is the spring force acting on it, spring force is equal to minus kx. That is correct. But if I ask you and the external force, that is why it is kx, it is in positive direction. And if I say that what is the net force, so this is fs plus f external, right? That is equal to 0 because two
So
forces are acting on it. Right? So net force acting on it is 0. So it means when you're pulling it to the right or you're compressing it to the left, then you have to do some work on it, right? It means you have to spend some amount of energy on it, and that energy gets stored in it in the form of potential energy. So when you're calculating the potential energy, you have to find out the work done by your force, external force, not the work done by the spring force, right? But your force, when you're pulling it on this side, your force should always be equal and opposite to the spring force. Clear this thing? So that's what happens. Okay, now tell me what is the work done? So here potential energy.
could you explain this again? I kind of got
Okay,
confused.
I'm just writing it down here so that you'll remember it. So potential energy simply means work done by external agency. Work done by external agency. It means not the work done by spring force. It means work done by external force, right? Not
No, sir. Could you explain like how F net? we got F net as 0.
Oh, just see that. When you're pulling it, it is a stationary, right? What it is, it is a stationary.
Yes, sir.
If you hold it into this position, x is equal to x1 position, then it is a stationary. Stationary means A is equal to 0. And according to Newton's law, F external, F net is equal to what? Ma. Very simple. And F net
Yes.
is equal to what? F net is equal to F net is equal to what? To the vector sum of all the forces acting on it. Right? Vector sum of all the
Okay,
forces
sir.
acting on it. Yeah. So gravity, we are not taking it into account, and normal reaction because they cancel out each other. So we will not take that into account. Horizontally, only two forces are acting on it.
Hmm. Okay,
Spring
sir.
force and the
So
force that
I
you're
thought
applying to the
this is
right.
like from where we've taken x is equal to 0 to x1. But so we're
Yeah,
taking it as
zero.
at rest, no, at
Yeah,
x.
at x1. Like you have pulled it to the x1 position, you're holding it in that position, right?
Okay.
And so in that case, you have to keep applying that amount of force. Otherwise, it will not stay at rest there. So in that case, this is the case, right? Now, so how much work you have done in bringing it from x to x1 position, that is what we meant by the potential energy, work done by the external agency. Okay, now what formulas you have learned about work done? Can we use this formula F dot S or Fs cos theta? Can we use this thing to find out the work done by the external agency?
Yes, sir.
No, we cannot use this formula, right? Because this formula is valid for constant force only,
Hmm.
right? Work done will be calculated by F dot ds vector integration.
Hmm.
Just a second. So here, FDR, you can take this thing R1 to R2, right? This is the case.
So where
R1
are
vector
we?
to R1 position vector from one position to another position vector, right? Or you can simply use this thing, or it is a vector form. If you want to do this thing, F dx from x1 to x2. Simple. That is the thing. F dx, you can say that this is the scalar form. This is the vector form. Just a second, there is one thing. Okay, now just see this thing here. If we calculate this thing, work done. If I try to calculate the work done by the force, external force, work done is equal to, let us say that 0 to x, F dx. In this case, why I'm taking this thing, cos theta will be 0 degree. Just see this thing. It is 0 because if the external force is in this direction, then the displacement is also in this direction, right? They are
Yes.
always in the same direction. When the force and displacement are in the same direction, then theta is equal to 0 degree between them. That is cos 0 degree is equal to 1, right? So we can simply just write it down as 0 to x f dx. Now f is equal to what? In this case, you can just forget about this negative sign. You just simply say that how much force you're applying. You see that Fs is equal to minus Kx, but F external is equal to what? Exactly equal to that much, right? That is Kx. And this force is external force. Okay.
So how is it
So
equal?
because it has to be equal, that is the definition of potential energy. Whenever you're pulling it, when you're doing the work, the force, external force needs to be the same as this spring force at every instant.
Okay, sir.
Right. That is, it means when you're moving it, you have to move it without changing the kinetic energy or without acceleration. And this can be done in a very slow manner. That's a very technical thing. But you just remember this thing, that this thing, right? Force and external force and spring force are always in the opposite direction.
So but they're equal and opposite forces then.
Equal and opposite forces. Whenever you're finding out the potential energy, whether the electrical potential energy or you're finding out the potential energy of any force, it is always equal and opposite.
Okay, sir.
Like, so try to understand this thing from here. Like, let us say that the mass is here, m. If you raise it to the h height, what is the potential energy? It is still work done by external agency, right? Just see that here at every interval of time, every interval of time, how much force is acting by the gravity? Gravity is acting downward, right? But when you're lifting it, you are applying an external force exactly same as mg in the upward direction. And the force and displacement are in the same direction. Just see that work force is equal to mg and displacement is equal to h. So it is mgh, right? It is exactly the same thing. Potential energy is always work done by external agency. Is that clear? Not work done. This is the concept, and just see that, but the concept of potential energy comes in the case of conservative forces only. There is no concept of potential energy in the case of non-conservative forces. Like there is no potential energy of frictional force. Frictional force is a non-conservative force. So whenever you're talking about potential energy, you're dealing with conservative force, right?
So
So M,
conservative forces were the ones that did not depend on the path, right?
yes, it is path independent, right? It's path independent. Okay.
Yes, sir.
Okay, so now let's just put this. Now you can easily figure it out. 0 to x, f is equal to kx and dx. K comes out. Tell me what you get. 0 to x, x dx. Integration of this thing is equal to what?
So x minus
8
0.
x squared by 2, right?
Yes,
Integration
sir.
0 to x, that is kx squared by 2. That is the potential energy, very simple. This is the work done and this is equal to potential energy. Okay, simple. You got this thing? Whenever you're finding out the work done by a variable force, you will never use that formula. This formula, we are so used to using this formula at in every case. No. For variable forces, you will use these formulas, right? Variable forces. For this thing, force is constant. If you plot the graph of this thing, force versus displacement graph, force is always constant. So you're finding out the area like this. Very simple. Force into displacement, right? Length into breadth. That's it. Nothing else. Here is the force, here is the, but in this case, your graph would look like anything, something like this. Suppose force and displacement. Then you have to find out the area under the curve. Area under the curve. And that is equal to, like you will cut down this is dr, and f is changing with position. So that is why work done is equal to integration of f dr from x1 to x2. In whatever range you are finding out this thing, let us say that this is x1 to x2, you will figure out the total area under the curve. That is the work done.
Okay, sir.
Yeah. Okay, Now about a spring force, I want to give you some important informations
So
here.
one second, I'm
Uh,
just writing it down. One
yeah.
second. Yes. So in this, how did F net become positive? No, sir. How did
Uh,
F external? How is it positive? Oh, because it's an equal and opposite force.
yes, equal and opposite force, right?
Okay.
Equal and opposite force.
Yes, sir. Done.
Okay, there are certain questions that are asked. Something like, there is a question we can do. Mm, yeah, but such small, just such simple questions are not asked in the exam. Questions are very complicated. Let me take one question. Okay, let's do that problem. On the way, I'll just explain those things. This is from question number, this is 2022, question number 4. Questions are difficult.
So, uh, so what did you say? Which one?
This one.
This is
2022.
So I feel like
Uh,
2020 had like tougher questions in other years.
okay. Okay, but in this case, simple harmonic motion is also involved. Did you see simple harmonic motion
Yes, I went through the definitions and the derivations.
formulas,
Yeah.
derivations and formulas, right? Okay, then we can just do this thing here. See, this is a very complicated problem, but let us try to understand the complications of this spring force things. There are other questions as well on spring force. Let's see. Can do a simpler one. It's a bit complicated. Involves lot of principles here. Yeah, we'll do this question a little later, but first we'll do a simpler one. Do this one. A solid block on a frictionless surface. So surface is frictionless. This is from 2019. Okay. Okay, so a solid block on a frictionless surface is connected to two rigid supports on the left and the right side by springs of spring constant K and 4K. So see, spring constant are not the same, respectively, as shown in the figure. The time spent by the block in a complete cycle of oscillation on the left and the right side of the equilibrium position are TL and TR, respectively. Which of the following is correct? Time spent by the block in a complete cycle of oscillation on the left, the right side. Okay, what does it mean? Just see that. What does TL means? TL means it will go to the left and then it will again come back to the same position. Right? This is the TL time. And TR means it will just see that when it tries to go to the TR side, this is the thing. Now try to figure out the answer.
So your voice, it was getting cut, so I didn't hear any of the explanation for TR.
Okay, okay. Is it clear now?
Yes, sir. So the
Okay.
video froze and it completely went.
Okay. So just see that when I say that TL is the time taken to complete the left journey, right? So this is we start from the mean position. This is the mean position. Here we will take that x is equal to 0. So it will go this side and then again come back to the same position. This is called the time taken to complete this journey is TL. It will go to the right and then again just see that in this case, what will happen? This will continue going to the right and then again come back to the same position. This is called TR, right? Now, because the spring constants are not the same, then the time taken, what will be the time taken for the left journey or the right journey? Just see that on the left side, there is a spring with a spring constant K only. And on the right side, there is a spring with a spring constant 4K. Okay, I didn't tell you the meaning of the spring constant here. A K is what? K is spring constant. Spring constant. What does that mean? F is equal to just see that if you'll understand the meaning of spring constant from here. F is equal to minus K. So what is the unit of K? Can you tell me what is the unit of K? Newton per meter?
Yes, sir.
Newton per meter. It means the force required to produce a unit extension or compression is called spring constant, and that is fixed for a particular material, right? It is different for different materials, but it is fixed for a particular material. It depends on the nature of the material that the force required to can simply understand this in the force required to produce produce unit extension. And whether we talk about extension or compression, it means the same. Same force will be required. Just a second. Just a second. Right?
Yes.
Okay. So force required to produce unit extension is called spring constant. So, and that depends on the nature, right? Fixed for a particular material. Fixed depends on the nature of the material. It doesn't depend on other factors. It depends on the nature of the material. Depends on the nature of the material. It means how stiff is the material. If the material is not that strong, it will produce, if you apply a certain amount of force, it will produce a greater extension because it is more flexible, right? You can clearly you can say that it is the measure of flexibility of the spring. If the K is less, it is more flexible. If K is very more, it is very difficult to extend the spring, right?
Yes.
It means for like greater the K, greater will be the force required to produce
So
unit
just give me a
extension.
second, sir. 1 second, sir.
Okay.
Yes. Sorry.
Yeah. So that is the thing here. Now, based on this thing, can you answer this question? Just see that you can understand the meaning of this thing. If there is a spring with a spring constant K, if you want to produce X extension here, how much force is required to produce X extension? If you want to produce this extension.
So, like the net force or the external?
Yeah, net force required to produce this much extension. It is simply Kx, right?
Yes,
Kx,
yes, sir.
Kx force is required. But if the spring constant is 4K, now in order to produce the same extension, extension, you need required 4Kx force. That is 4 times as big as the first one, right? So more force is required. So depending on that thing, on that logic, you have to figure out the correct answer to this question.
So, D.
D. Okay, why did you say that?
Simply because it's like 4 times.
No, D is the wrong answer.
So, is it A?
A, why do you say A?
So, I use the time period formula.
Time period formula.
So then the one in which
Uh,
it's inertia factor by spring factor. So
okay.
that's the
In this case, I exactly they have just twisted the question. This is not that a very difficult question, but don't even need to solve anything here. Just see here what you have to do. Because there are rigid walls on both the sides, okay, they are not going to change the position. So position will remain the same. Spring extension, let us say that when it goes, let's just say that this is, let us say that in a particular case, when the spring goes to this side, goes to this side, in this case, this will compress, right? This spring will compress
yes, sir.
and this spring will extend. That's correct, right? So
Yes,
let us
sir.
say that compression is X. Let us say that compression is, it compresses by X amount. So extension will also be, extension in the spring will also be X, right?
Yes, sir.
It means just see this thing here. It is the X is equal to 0. It means at any interval of time, the extension in both the sides will be exactly the same. It goes X position this side. So it is here, then it comes here, then it will go this side. When here X extension happens, then the X compression happens here, then the X extension will happen here as well. Um, yeah, there's one more thing. And what is the net force acting when it is going in this direction? Tell me.
So towards right.
Yeah, net force acting on the system when it is on this side. Let us say that at this position, at X position. So at this position, just see that this spring will apply because it is compressed. This will apply a force on this direction, right? That is Kx force. Spring will apply. If you compress the spring, spring will try to uncompress it. If you extend the spring, it will try to, you know, reduce its. It is very, very obvious, right? It is
Yes,
just see that if this is spring, just see that if you try to stretch it, it will try to unstretch itself. It means if external force is trying to stretch it, spring force will try to unstretch itself. And similarly, if there is a spring, if you try to compress it by external force, spring will try to uncompress itself. Very simple. So spring force has a tendency to keep it in the same state, right? All the time. It has a tendency to keep it in the same state. So just tell me what is the net force acting at this point? Kx spring, this is spring. Let us say first spring will be applying force in this because you are compressing it. So it will try to uncompress itself towards the right. So spring force will come into play in the right direction. Did you get this thing?
it's in the left direction, right?
Yeah. No, no, no. You compressed it to the left
Yes,
direction.
right. Yes, sir. Yes, sir. If you're pulling it, yes,
Yeah.
sir.
So if it is compressing, if you're compressing it, spring is trying to uncompress itself by applying a force, Kx force. So let's just talk about the spring force here. So that is the thing. And this is also applying a force on it because you're stretching it. Just see that. In this case, you're stretching it. So this will apply how much force? This will apply 4kx in this direction. Okay. So net force acting on it is actually equal to 5kx.
So, but so if you're compressing the spring,
Okay,
so
let's just try to understand this thing from here. If suppose there was only one spring, if you compress it to this position, okay, it means spring force will be in which direction? This direction. Getting it?
yes, sir.
If you compress it, that is the case. Spring force is in this direction, and that will be exactly equal to kx. Forget about the sign at this time. Just think about the magnitude because direction we already know, right? And now, similarly, if there is a spring, if you try to stretch it to this position, in this case also spring force will be acting in this direction because spring force is always directed towards the mean position. Just see this thing. Fs will be kx, right?
Yes, sir.
So it means the moment you do this thing, so this net force of 5kx will try to bring it back to the x0 position.
Yes, sir.
That is the
So
thing.
that's what
It means
compression.
net, yeah. So it means the moment you like this is the stationary equilibrium position. The moment you disturb this state, you shift it to this direction and just leave it by just by bringing it here, right? And by extending it here, compressing this spring and extending this spring, then you need to apply 5kx amount of force on the left direction, right? And that will, because and the moment you leave it, just tell me at this particular point,
Wait, sir.
this is the,
Five
yeah,
px will be applied in the left direction. So when
yes,
I put
external
it
force
right,
is equal to, yeah, 5kx. So spring force will come into play 5kx, right, on this direction. Is that clear? You applied 5k in order to disturb this position, you need
so wait,
5kx
we're
amount of
extending
force.
it right now. Also, we're compressing it.
Yes, both the things are happening simultaneously because of the arrangement like this, right? Do you see this thing?
Oh, okay. Yes, sir. Yes, sir. Okay,
So
sir.
one spring is compressing and the other spring is stretching, right? That is the
Yes.
thing. So in that case, in order to disturb this position at any interval of time, you always have to apply this amount of force, 5kx amount of force.
Yes.
And the restoring force will always come into play, that is 5kx amount of restoring force.
Yes, sir.
Zero, the only force remaining is this force, right? The moment you're holding it here, the moment you leave this thing, it will again try to come back to this position, but by inertia, it will continue to move in this direction. And then again, by inertia, it will come back to this position and again do this thing. So what will happen? It will just keep oscillating between the same position. And at any interval of time, this X position will remain exactly the same. It means amplitude becomes the same. Amplitude is equal to X and restoring force F is equal to minus 5kx. You can say that. It means whenever this happens, whenever a force can be expressed in this format, like F is equal to minus kx format, and in this case, just see that this is a constant. So that is a simple harmonic force. It means In this case, it will perform simple harmonic motion. And in simple harmonic motion, the time taken to cover the left distance and the right distance is always the same. C is the right answer. This is a simple harmonic motion question.
Yes, sir.
Bit difficult. Tell me, you got this thing or you're confused?
So I got it. Like, so even when I solved it, it came down between A and C. So
In
because
A
first
and
I
C,
thought
right?
it will be C, but then
Yeah.
sir was calculating and then that way it made more sense with A. But yeah,
Okay, so just see that ASC is the right answer, right? Why? Because in this case, SHM will happen. This will perform an SHM. And in SHM, always the time period is fixed. It's not different for left and right.
yes, sir.
Okay, okay, this one was a bit easier to solve, but this one, let us just do this question as well. At least you have an idea. This will give you a better idea, better scope of the question. Lots of different things have been mentioned here. SHM and spring force has been mentioned over here. As shown in the figure, block is resting on a frictionless floor and is attached to the free end of the spring. The right edge of the block is in equilibrium. So this is the equilibrium state given to you at a distance d from the wall. So this is d distance. When the spring is compressed by d by 2 distance and released, when the spring is compressed by d by 2 distance, the time period of the motion is t. Okay, so when the distance compressed by a distance of d by 2, so then the time period is t. Similarly, when compressed by 2d and released, then the time period is t naught. Considering elastic collision between the block and the wall, what is the value of the quantity T naught by T? Yes. Give it a try. Like, can you tell me what approach we can take to solve this question? In this case, also the block will execute simple harmonic motion, but just see that in the second case, when you extended it or compressed it by d by 2 distance, then it's okay. It will be extended by d by 2 distance here. No problem with that thing. But the moment you take 2d distance, 2d distance, then it will also take 2d distance here.
Yes,
But then this wall will block it and the collision will happen while going towards this thing. So then it will stay here and then it will start moving from here. So obviously in this case, it is traveling a shorter distance in this case. It is going here and then coming back here in the right direction. But in this case, it is going in this direction and then coming back this thing. In this case, it is completing entire 2D distance. But in this case, it is completing only D distance. And then you have to figure out the time period for T and T naught by T. So T is very, very simple. Have you gone through the formulas of this thing?
so the I have one factor of simple harmonic motion.
Oh, sorry, I didn't hear you. It was frozen. What did you say?
So I have the formula I went through was is equal to the time period in SHM is equal to 2 pi by root of inertia factor by spring factor.
Yes. So 2 pi root over m by k is the time
Yes.
period. Inertial factor means mass. Mass is the measure of inertia. And spring
Hmm.
constant, k is the measure of a spring constant. Simple, right? So time period is equal to 2 pi root over m by k. So you just
So you
remember
just
that
remember
thing.
that thing.
Time period and omega are completely independent. Time period can also be given by this thing. Time period is equal to 2 pi by omega also. That is also one of the
Yes.
formulas. That's one thing. And here just see that there are two cases. First case is very, very obvious. Um, okay, let's just solve it together. When when the spring is compressed by a distance d by 2 and released, then there is no issue, right? It will complete the journey in within this range. So the entire motion will be completed, no issue. Let us say that for this motion, the time period is it will go here and then come back here and then it will go there and then come back here. One journey is complete. And let us say that for this thing, the time period is t, no, t, simple, right? It is the time period t. So, and this t is given by this thing, 2 pi by omega, right? Simple. It is the thing. So we can say that the time period is equal to t is equal to this much, 2 pi by omega. Or you can say that this thing is also, you can write anything, that's fine. Let's use this one because this is simpler one. So time period is equal to 2 pi by omega. For the second one, it is a bit complicated. Now for the second case, in this case, this was the first case. Time period is given by this much. In the second case, now we are taking 2D distance. It was supposed to be in this direction, right? Suppose like this distance. DD 2D. So it will be something like this. You will compress it up to this much. From here to here, this is 2D distance. So in this case, what will happen? This spring will go this side, cover 2D distance, come back to this position, cover 2D distance. But when it is going this side, it will cover only D distance and the collision will take place. Here, collision will
Yeah.
take place and then it will come back again, right? Here, this is the thing.
Yes.
So in this case, but just see that whatever we just solved this problem, right? This is the TL and this is the TR and the TL is always equal to TR. This will remain because imagine that if there wasn't any wall, then it would have completed the entire distance, right? Like here, and the time taken would have been exactly the same. So what will happen? It will spend some time during the collision. It will come to a halt and the velocity will be reversed. Just see that. Let us say that the moment it will collide with this thing, the velocity was v because it has been mentioned that the collision is elastic collision. Just see that it is mentioned. So during the elastic collision, there is no loss of kinetic energy. Kinetic energy will remain the same. So it was going in this direction when it collided with this thing, but after collision, it will come back with the same velocity in this direction, right? It means the time taken will always be the same. During the collision, it will remain uh, in contact with the wall for some time, and then again, it will come back to this direction. And it will cover the distance in the same amount of time. Okay, that is the key idea to do this. Can you now think of an answer?
So it's basically going to be the same, right?
Yeah, but in this case, we have to find out just, okay, it may be different here. Just see this. In this case, because the collision is taking place, it will be different. It will be, yeah, it will be different. So in this case, just see that in this case, T naught will be equal to TL plus TR, right? Simple.
Yes, sir.
TL plus TR. Now, there's one thing we have to do here. Hmm, the time taken, it has been when the compressed by 2D distance released. The time period is T naught, considering the elastic collision between the block and the wall. What is the value of this thing? Mm, okay, double the distance of that thing. A bit complicated concept has been used here. No, no, no. In this case, the time taken by right this thing, left one will be different than TR because the collision is taking place, right? Due to collision, the time will be affected. The TR will be different from TL. TL is very, very simple, right? As far as TL is concerned, just tell me what will happen. This is the spring here. It goes to this direction, 2D distance, and then comes back to the same position, right? Just imagine that there is no wall for this kind of motion. Then it will go here and then again come back to this thing, right? So the motion in this case, just consider only the half motion. If the total time period is T, right? So in this case, what will happen? Just see that time period. One very important this thing, that time period, according to this formula, why we wrote this formula, time period is independent of independent of amplitude. This is very, very important. Is there any amplitude in the formula? There is no formula. It means if the amplitude is D, then also the time period will be T. If the amplitude is 2D, then also the time period will be T. Okay. Did you get this point?
Yes,
Time
sir.
period is independent of amplitude. So it doesn't matter what is the amplitude of this thing. It totally depends on the property of the material, spring material, inertial property of the object and the spring constant. That's it. It doesn't depend on the amplitude. So the time period will still be T naught will be in this case T. So this journey will take T by 2 amount, right? Half of this journey.
Yes, sir.
So in this case, TL will be simply T by 2. Now, the only complicated part that we have to resolve is this thing. What is TR? Right, that is the difficult part that we need to find out. So in order to do that, we will do one thing. Let us say that it was executing a simple harmonic motion. If there was no, imagine that there is no wall just before the collision. It is executing simple harmonic motion, right? And in this case, what is the amplitude here for this motion? 2D, right? Amplitude is 2D. Hello, Durwa, can you hear me? Hello.
Sir, am I audible properly?
Yes, I can hear you.
Okay, sir. And I'm visible as well, right?
No, not visible. It's totally black.
Oh,
Now I can see. Yeah.
okay, sir.
See. Okay, one part is clear. So one thing is very, very obvious that TR is not equal to TL in this case, right? TR will be different because of the collision.
So can
So
you
that,
explain this question like from the starting? I got a
okay, okay,
little confused in the middle.
okay. So in this case, it is asking that when the displacement, like when you compress the spring by d by 2 amount, then the time period is t, right? This t is equal to this much. T is equal to 2 pi by root over n by k, or t is equal to 2 pi by omega. It's the same thing, right? That is the thing. So in this case, time period is this thing because it is within the limits. It can complete the entire journey like without any resistance, right? Without any collision. But when you when you compress it by 2D amount, which is here, 2D amount, then left journey there is no resistance. But during the right journey there is a collision, right? So it says that during this time, the time period is T naught, and T naught is equal to very simple TL plus TR, TL plus TR. And in this case, we just figured out that TL is equal to simply T by 2 because time period does not depend on the amplitude. So it means even if the amplitude is 2D, then the time period will still be T, right? So for half journey, it will be just T by 2. But the moment it starts right journey, it doesn't even know that something unusual is going to happen unless it collides with the wall. The moment it collides with the wall, everything changes, right? Then the time period changes in that case. So it will collide with the wall when the time period is sorry, when the x is equal to d here, right? But during this right journey also, during the right journey, before collision, the block is still executing simple harmonic motion. The moment it collides with the wall, something changes there, right? But just see that just before the collision, it was performing these things, SHM motion. So what is the, an SHM motion is given as this thing. X is equal to, do you know this formula? Amplitude is equal to A sine omega t.
Yes, sir. Yes, sir.
This is the formula. And in this case, what is the amplitude for this second motion? 2D, right? X is equal to 2D sine omega
Yes.
t. That is the thing. So when it has covered this much distance, only d distance here. So what is the time taken to complete the journey from here to here? We can get that time and we'll just double that time, right? So when x is equal to d, what is the time elapsed? We can find out from this formula. So just see this thing. dd, you got this thing? How I did it? This is the most important thing. And
Yes,
then
sir.
everything is, then sine omega t is equal to simply 1 over 2. That is equal to sine, sorry, omega t is equal to sine inverse 1 by 2. That is equal to what? Pi by 6, right?
Mm.
30 degree, right? 30 degree.
Yes.
So T will be equal to what? Pi by 6 omega.
Yes, sir.
So therefore TR will simply be 2 times T. That is 2 times pi by 6 omega. That is pi by 3 omega. We got it, right? TR we got it. So therefore T naught will be equal to T by 2 plus pi by 3 omega. Now T we already know. Since T is equal to 2 pi by omega, just put that value. This will be equal to pi by omega plus pi by 3 omega. That is equal to how much?
So 1
3,
by 2.
1 by
So 1 by 2 pi by omega.
1 by
So basically
2.
pi by 2 omega. No, sir. Sorry, sir. Uh,
No, no.
sir, it would
It will be
be
4 pi by 3 omega,
4
right?
pi, yes,
4
sir.
pi
Yes.
by
3.
3 omega. And if you just do this thing here, now put omega is equal to 2 pi by omega, 2 pi by t. 4 pi by 3, 2 pi by t. This thing you will get 4 pi by 6 pi into t. Pi pi cancel, 2 into 3. 2 over 3t. 2 over 3t. You're getting
This is a A.
A is the correct answer, right? You got it. So this is 2 over 3t. So therefore, t naught by t is simply equal to 2 by 3t by t, that is equal to 2 by 3. That is the A answer. This was a difficult question, but see that there are so many things involved here. Did you
So,
get the
sir,
point?
this.
Yes.
So, while it was being pulled, right? While it was being compressed, it was T.
Yeah. Just remember once again, I'm just explaining it here. Just see that first case. In the first case, what is the amplitude? First motion, d by 2, right?
Yes, sir.
First motion, the amplitude is equal to d by 2. Time period will be simply equal to t. No problem. So in the second case, amplitude is equal to 2d. Time period will still be t. Why? Because this case, time period does not depend on the amplitude. Time period will still be 2, and in both the cases executing simple harmonic motion, just see that in both the cases, if you leave it, it will perform simple harmonic motion. So with the help of simple harmonic motion equation, we can find out the time it takes to cover d distance during the second motion before the collision, right? Just before the collision, it covered d distance. So when x is equal to d, how much time has been elapsed? With this formula, we can calculate this thing. So, and TR will be simply double of this thing, total time. Getting it? If it takes T time here to here, it will take exactly T amount of time, because while reversing, because of the elastic collision, when it hit the wall, it was traveling with v velocity. Just before hitting the wall, it had v velocity. But after collision, because in the elastic collision, kinetic energy is not lost, it will still have the backward motion will be exactly, backward velocity will exactly be v. It will gain the entire kinetic energy. So it will take exactly same amount of time to reach the x is equal to this mean position. So that is why these two times will be exactly the same. Just TR will be equal to simply 2t. And t we can figure out from this equation. T we can figure out from this equation. So once t is figured out, just double it. You will get TR, and then simply do this thing. TR is T naught is equal to what? T naught is simply equal to what? TL plus TR. That's it. TL is equal to T by 2, TR is equal to pi by 3 omega, and you'll get it.
Okay, sir.
This was a difficult one, right?
Very difficult, sir.
Difficult. It is difficult. So they do not give easy questions.
Sir,
They just,
like instead of difficult, it's more like so many things together.
yes, that is the thing. They just, it is the synthesis of lots of concepts. They
The
are just
same
mixing the
thing
concept together.
is happening in maths, sir. Like one question will have three, four chapters combined.
Yes, that's what happens, right? So you don't have to know only the calculus, but you need to know matrices also, right? Determinants also. That is the case. Uh, okay, we can leave here today. Tomorrow, what time you want to have the session?
So I'll message you by the night because I have other classes as well.
Okay, okay, fine.
And should I revise any more chapters?
Yeah, same chapters. Do go through the chapters again and tell me if anything is not clear to you. We'll do it right here because we'll be doing. There are
So
so many
for
questions I've selected.
tension and all of that, sir. So for
Yeah,
tension and
tensions.
normal reactions, I only found like definitions and basic things. There was nothing too much.
Okay, okay,
Yes, sir.
okay. So I'll just make you do some conceptual questions based on those things. If you have good understanding, I'll just check it right tomorrow.
Okay.
And there are so many questions based on mechanics we still have to cover from these questions. So we'll do
So
it
from
tomorrow.
these chapters only.
Yeah. So
And
simple
so,
harmonic is the same.
what
Us.
about the mechanical properties? So none of that is there, right?
Yeah, mechanical properties we'll do it once we are finished with this one, mechanics, then we'll do mechanical properties. That's second book, right?
Yes.
Mechanical properties of and thermodynamics is also there. And that second book like photoelectric effect and other things, we'll do it.
Okay,
Okay.
sir.
Okay then. Bye.
Okay. Bye, sir. Thank you, sir.